Hello and welcome to another Logic Gate tutorial. This was an interesting one. This took me about 5 hours to work this out. And in a previous video I said something that I think is absolutely correct. Obviously I did. I'm brilliant. That you have to think it through, and I couldn't quite get my head around how to do what I wanted to happen. Now I'll explain. I've got two track lasers and I'm going to build a race, and it's going to be for the balls along the ball track. And what I wanted to happen was for something to go off when someone crossed the finish line, but also simultaneously turn off the losing side. Otherwise, when the loser came through, whichever side it would be, I'm picking this side for now, it would also trigger the celebratory side. And I didn't want it to do that. I only wanted it to celebrate on whichever side won. And so I had to, I really thought about how power worked, and I thought if this switches off it'll switch the other one, and if that switches off it'll switch this one. None of it worked. And the reason it doesn't work is the power of tripwires is sort of a bit backwards in my view, in so much as that they don't transmit power until tripped. I would have thought that they would cut power if tripped, and they don't. You can see that the green's here. And if I go across, the red's there, and it goes green, and it cuts power, but it doesn't. It actually enables power. So I had to introduce a NAND gate, and it's over here. And one of the nice things about logic gates is when you get them set up, as you can see in the green box just to the right there, you can see I've got two laser tripwires going in, and an AND logic gate there, and I have a NAND logic gate there. Effectively, they're complementing each other. They're both NANDs. I don't know why it said AND for a minute ago. Must have misread it there. They're both NANDs, which is not ANDs. And the way to think of a not AND is it will transmit power unless it gets power. Now, I know it makes no sense at all, but think of it like this, like a plane that would only take off if there's no passengers on board. If one passenger gets on board, it will say, I'm not going anywhere. And in this case, it will cut power. But that's no good to us because we want it to actually power something. So then I had to introduce an AND logic gate, which would power if it got no power. I know it doesn't make any sense at all, but it works. And I'm not going to mess with it anymore. And I can actually show this. If I've got a work light here, and just behind it is a flamethrower, which I'm going to enable in a minute. And if I go across this finish line, there's a work light there, and there's a work light there. This work light will come on, that will not, which makes sense. Done. And you can see the logic here is working, because it's sending power to the work light, which ultimately would send power to the flamethrower. But when I come to this one, it won't power that light, and will in fact turn both of them off. There you go. So let's re-enable them again, and I'll actually show it working the other way. And I have them going to two AND gates here. And that's the NAND logic gate coming there, and the laser tripwire, which is here. I have to power everything, and then send power to the logic gates for the logic gates to actually work. So this is a lot of complicated wiring for what effectively would be a simple thing on paper. But as I promised, if I walk through this one, this light will come on, that one will not. There we go. And if I go to now, the other ball's rolling down the hill and it's coming through and it's going to go through, but it's the losing ball. So it doesn't do anything. It just turns that off, which is fine. I don't care. By then the celebration will have already been triggered. Obviously you could also have a losing animation. I'm using that word in quotes, but you could have a losing routine as well. I'm not too worried about that. What I do intend to do is actually lock a settler in this area here. I've just built a wall around me for now, just so I can keep all settlers out while I'm working, and have them burn to death. Yes, gruesome as it is. So I'll repair that. In fact, before we do that, let's make sure we've reset. This would be the only problem with this setup, is there's no real way to repair things automated, as far as I know. I mean, I have to do it in the build mode. But I'll repair the flamethrower there, and the flamethrower here. And again, I use these lights. Oops, I tripped over my own tripwire. Hang on. I use these lights as my test. So that's just going to burn away there for a minute. So I use these work lights as my test before I bother with actually doing something fancy. Like in the previous video, in my game show, I had fireworks going off, which you could do very easily here. Right, everything is now reset. And if I built a trough here with a ball hopper coming out, maybe put some curves in it, have it going all complicated with lights being triggered, ultimately one of them, and it is real physics, will cross this line and it will cause a trapped settler, you know, whatever I want to put there to trigger, which in this case is a flamethrower, and we'll go all across the left, and there we go. Now you're going to say, well, go and do the other one quick, and watch what happens. Nothing. So even though the other ball will come through, it won't trigger this one, and vice versa. If this ball ended up winning, this one would trigger, which is ready to do. So let's do that. And that, and then reset our flamethrowers. We'll repair you. Hopefully I've got enough aluminium. Cost aluminium in this game's like gold, except harder to find. Right, and as before, I'm going to go through on the right here just to confirm that everything's working as it should. This flamethrower and this light will come on. Nothing will happen over here. There we go. And if I go through this one, nothing will happen over here. And that flamethrower will burn away whatever I put whatever I put there. Both of these logic gates have to talk to each other. And then both of them talk to an individual logic gate. These don't talk to each other. They don't have to, because the intelligent part has been done here. These are just to distribute depending on whether or not they get power. And so that's a section of logic gates where you could have a finish line in a race. You know, like I'm probably not going to build the actual race now that I've spent too much time on this. And I'm also not going to take too much time in breaking down the logic that I've got here. On paper it would be quite simple to write down, but because you have to power a non-powered gate just for it to understand what's going on, it can get quite wiry, as you can see, and it could be tucked away and neatly done, but obviously in the case of a tutorial I want to show it all. But I did sit down with a plan to make a race finish line be tripped on either side and only work on the side that won and disable the side that lost, and that's exactly what happens. This light comes on, that one doesn't, they both go off. It's fantastic. It works exactly as I intended in my head. It just took quite a bit of time to get there and involved the use of 4 logic gates, an AND and a NAND, and 2 generators. Please take a look at my other tutorials. They're not nearly as complicated as this if you get chance. My name is Vinny Voodoo. Thank you as ever for watching, and if you've got any questions about this or you'd like me to break down the logic, I'll be happy to do so if I can get my head around it myself. And thanks for watching.